Our universe is vast, but its strangest secrets are catalogued right next door. For over a century, astronomers have used a single, monumental map to navigate the deep sky, the new General Catalogue. It labels thousands of nebulae, star clusters, and galaxies, yet within its dry numerical listings hide sights that defy belief. We are going to explore 25 of the absolute strangest. You will see ghostly bubbles surrounding dead stars, galaxies twisted by cosmic collisions, and shapes in the void so peculiar they seem impossible. By the end, you will have a new map to the universe's most breathtaking oddities. How did a dying star create a perfect rectangle of light? What force could give a galaxy the appearance of a blinking eye? The answers lie in the NGC. What do you think is the most bizarre thing a star can become? Our journey into the strange begins with a phantom planet. Catalogued as NGC 3242, this object has a far more evocative name, the Ghost of Jupiter. Through a telescope, it reveals itself as a pale, glowing disk of greenish-blue light, roughly the same apparent size as the giant planet Jupiter, but this is no world. It is a shroud, the final breath of a star very much like our own Sun. When such a star exhausts its nuclear fuel, it does not go quietly. It casts off its outer layers in a series of violent pulses, creating a vast, expanding cloud of incandescent gas. The ultraviolet radiation from the tiny, hot stellar core left behind, now a white dwarf, makes that gas glow with an unearthly light. This is a planetary nebula, a cosmic misnomer from an era when their round shapes reminded early astronomers of distant planets. The Ghost of Jupiter is one of the finest examples in our sky. Look closer and its simple disk transforms. High-resolution images reveal a complex inner structure with looping filaments and a bright, elongated central region that gives it an almost eye-like quality, staring back at us from the depths of space. Surrounding the main nebula is a colossal, faint halo of gas, material ejected thousands of years before the main event, now illuminated by the fading echo of the star's death. This ghost is surprisingly bright, visible even in small telescopes from a dark sky site. To find it, you point your telescope toward the constellation Hydra, and there it hangs, a celestial spectre. It is a beautiful and haunting reminder that even an ordinary star like our Sun has a spectacular and ultimately fleeting finale waiting in the distant future. What other beautiful ghosts are hiding in the catalogue? From one ghostly gaze we move to another, this one far more menacing. The Black Eye Galaxy, officially NGC 4826, stares back at us with a single, brooding dark orb. This stunning spiral, located about 17 million light-years away in the constellation Coma Berenices, is a textbook example of a galaxy with one glaring exception. A thick, sweeping lane of cosmic dust spirals tightly around its brilliant core, blocking the light from billions of stars behind it. This is not a shadow, but a colossal cloud of soot and ice, a stellar nursery in its own right. Within those dark lanes, gas and dust are compressed by gravity, eventually igniting into new generations of stars. The Black Eye is actually a place of violent, beautiful creation, a reminder that darkness in space often precedes brilliant light. But the true strangeness of the Black Eye Galaxy lies in a hidden motion that defies expectations. Astronomers studying the movement of its stars made a startling discovery. The stars and gas in the galaxy's bright inner region rotate in one direction, as you would predict. However, the material in the vast, faint outer halo rotates in the exact opposite direction. It is as if the galaxy has two distinct components spinning against each other, a cosmic contradiction. The leading theory suggests a dramatic past. The Black Eye Galaxy likely cannibalized a smaller, gas-rich companion galaxy billions of years ago. During this violent merger, the incoming galaxy was torn apart, its stars and gas splashing into an opposite rotating stream that eventually settled into the outer halo we see today. This galaxy wears the evidence of its ancient feast not just in its dark band of dust, but in the very motion of its stars, a permanent record of a long-finished cosmic collision. What other galactic secrets are written in the way they spin? This cosmic face peering from the void offers a more intimate and strangely familiar portrait of stellar death. Catalogued as NGC 2392, the Eskimo Nebula presents an almost human countenance floating in deep space. Through a telescope, you first see a bright, bluish central disk that resembles a face. Encircling it is a complex halo of glowing gas filaments, arranged with an uncanny symmetry that looks exactly like the fur-trimmed hood of a parka. It is an illusion, of course, a chance alignment of physics and perspective, but one so compelling it has defined this object for centuries. William Herschel, who discovered it in 1787, saw a disk with a faint surrounding ring. Modern telescopes, however, reveal a structure of breathtaking complexity. The face is the inner shell of the nebula, a bubble of gas blown into space by the dying star's core roughly 10,000 years ago. The fur parka is an older, larger shell, ejected during an earlier phase of the star's demise. But the detail is what astonishes. The outer shell is not smooth. It is filled with strange, comet-like filaments, each one pointing radially away from the central star like streaks of cosmic frost. How does a simple, spherical star create such an intricate, layered sculpture? The answer lies in a celestial tug of war between winds. In its final throes, the star first puffed away its outer atmosphere in a relatively slow, dense wind. Later, as the exposed core heated up, it unleashed a torrent of intensely fast, low-density particles. This supersonic stellar wind caught up with the earlier, slower ejector and plowed into it, sculpting the material. The comet-like filaments in the parka are thought to be where dense knots of older gas are being shaped and eroded by this relentless faster wind, creating brilliant tails that stream outward. The inner face glows fiercely in the ultraviolet light of the central white dwarf, a stellar ember hotter than the surface of our Sun. Remarkably, this entire cosmic portrait is within reach of amateur astronomers. Located in the constellation Gemini, the Eskimo Nebula shines brightly enough to be seen as a non-stellar blur in small telescopes, with its distinctive shape emerging under darker skies and higher magnification. We are looking at the final artistic statement of a star, a self-portrait painted with its own expelled atmosphere, frozen in time for our observation. It makes you wonder what delicate processes are currently unfolding, unseen, within other dying stars across the galaxy. While the Eskimo Nebula shows a star's final portrait, some celestial structures are captured at the very beginning of a much grander transformation. Drifting through the dense heart of the Virgo cluster, a massive gathering of galaxies, two spirals are locked in the opening steps of a cosmic waltz. Known together as the Siamese Twins, their catalogue entries are separate, NGC 4567 and NGC 4568, but their fates are now inseparably intertwined. Through a telescope, they appear as two glowing ovals of light in close contact, their spiral arms beginning to blur and distort under each other's immense gravitational pull. They are not yet colliding in a violent crash, but are instead engaged in a slow, graceful, and inevitable dance that has already lasted millions of years. A faint, ethereal bridge of stars and gas is beginning to stretch between them, a tangible thread of gravity pulling them closer with every passing orbit. This delicate connection is the first visible sign of a merger in progress, a process that will utterly reshape both galaxies. Right now, their individual cores remain distinct, separated by about 20,000 light-years, a distance that is cosmically intimate. They are close enough to feel each other's presence profoundly, warping each other's structures, yet still far enough apart to retain their individual identities. But this is a temporary state. Over the next several 100 million years, their gravitational embrace will tighten. Their beautiful spiral arms, the very features that define them, will be drawn out into long, streaming tidal tails of stars flung into the darkness. Their cores will swing past each other in increasingly close passes, stirring up vast clouds of gas and triggering firestorms of new star formation. Eventually, after multiple close encounters, they will settle into a single new galaxy, likely an elliptical shape, their stellar populations forever mixed. The Siamese twins offer us a rare, frozen moment in this billion-year-long process. We are witnessing not a catastrophe, but a creation. From this union will emerge something entirely new, a testament to the dynamic, ever-changing nature of the universe where even galaxies are not permanent islands, but participants in an endless cycle of interaction and rebirth. What other silent dances are unfolding in the darkness, too slow for any human lifetime to perceive? Sometimes the universe plays tricks on the human eye. Among the most famous is NGC 6826, the Blinking Planetary Nebula. Gaze directly at it through a telescope eyepiece, and you might see only its brilliant, hot central star. But shift your gaze slightly to the side, using averted vision, and the entire ghostly green disk of the nebula itself suddenly materializes around it. Look back directly, and it vanishes again, as if winking in and out of existence. This eerie effect is not a property of the nebula itself, but a remarkable quirk of our own biology. The central region of our retina, the fovea, is packed with cone cells perfect for detecting color and fine detail in bright light. Surrounding it are the rod cells, far more sensitive to faint light and motion, but seeing only in shades of gray. When you stare directly at a faint, diffuse object like this nebula, its light falls on the less sensitive cones and it disappears. But when you look away, its light falls on the rod-rich periphery of your vision, allowing the faint glow to pop into view. It is a perfect demonstration of how our perception is an active participant in observing the cosmos. The nebula itself is a masterpiece of subtle structure. That overpowering central star is a white dwarf, the exposed core of the progenitor star, blazing with enough ultraviolet radiation to make the surrounding gases fluoresce. But the real challenge for observers lies in spotting its two faint, fast-moving lobes. These are symmetrical bubbles of gas ejected from the star's poles at tremendous speeds long before the main shell was formed. They are expanding so rapidly that in just a few years, sensitive instruments can measure their movement against the background of space. To see them visually is considered a supreme test of telescope aperture and sky darkness, a whispered trophy among amateur astronomers. The Blinking Planetary, then, is a double mystery. It hides its true form not only in the vastness of space, but within the very limitations of our sight, reminding us that every observation is a conversation between the distant cosmos and the fragile human body attempting to perceive it. The Blinking Nebula plays on the limits of human sight, but the next object presents a form so distinct it feels like a cosmic sculpture. The Saturn Nebula, catalogued as NGC 7009, earns its name from an uncanny visual trick. When viewed through a telescope of William Herschel's era, its elliptical disk appeared flanked by two faint, protruding extensions, reminiscent of Saturn and its rings seen edge-on. These extensions are not rings at all, but brilliant, fast-moving jets of gas streaming from the central star. Astronomers call these features ansi, a Latin word meaning handles, and they transform this nebula from a simple glowing cloud into a dynamic, three-dimensional structure. At the heart of it all lies a fiercely hot white dwarf, one of the hottest stellar remnants known, blazing with a surface temperature over 10 times that of our Sun. In its final death throes, this star did not eject its atmosphere evenly in all directions. Instead, it funneled material outward at incredible speeds from its poles, creating those two opposing jets that now stretch like searchlight beams into the surrounding shell of slower-moving gas. We are seeing a stellar engine firing in two precise directions, carving its signature into the nebula. The complexity does not end there. high-resolution images reveal a nested series of shells and bubbles within the main structure. The innermost region glows a vivid blue-green from the light of ionized oxygen, while outer filaments shine red from excited hydrogen gas. This colorful layering is a timeline of the star's death, with each shell representing a different pulse of ejected material. Historically, the Saturn Nebula holds a special place. It was among the very first planetary nebulae ever discovered, identified by William Herschel himself in 1782, just a few years after he coined the term planetary nebula. Its striking, definable shape helped early astronomers recognize these objects as a distinct class, not just fuzzy stars or unresolved galaxies. For the modern astrophotographer, it is a prized target, its compact size and high surface brightness allowing cameras to capture its stunning aquamarine and rose hues against the black of space. It serves as a brilliant reminder that the end of a star is not a messy explosion, but often a precise, almost architectural process where physics sculpts gas into forms of unexpected and haunting beauty. What other intricate shapes has stellar death etched across the galaxy? The architectural beauty of stellar death gives way to the silent, frozen elegance of an entire galaxy. The Spindle galaxy, catalogued as NGC 5866, hangs in the void like a celestial jewel cut with impossible precision. Seen perfectly edge-on from our vantage point, it presents itself as a long, slender needle of light, a luminous spindle floating against the darkness. This striking shape reveals its true nature as a lenticular galaxy, designated Type S0, a cosmic hybrid caught between two worlds. It possesses the flattened disk and central bulge of a spiral galaxy like our Milky Way, but it has almost entirely exhausted the gas needed to form new stars. Its spiral arms, if they ever existed, have faded into a smooth, featureless glow, leaving behind a population of ancient, aging stars that orbit in quiet, settled harmony. The galaxy is a fossil of a more active past, a stellar system that has largely finished its era of vibrant creation and now exists in a state of serene maturity. Yet cutting across its middle, splitting the bright disk perfectly in half, is a dark, razor-sharp lane of cosmic dust. This band is so thin and so precisely aligned along the galaxy's equator that it looks like it was drawn with a ruler, a stark division between the glow above and below. This dust lane is the source of an ongoing cosmic debate. Its presence is a hallmark of spiral galaxies, where such dark material fuels ongoing star birth. In a lenticular galaxy, which is supposed to be gas-poor and quiescent, such a prominent and well-defined dust lane is a surprise. It forces astronomers to question whether the Spindle galaxy is a true lenticular, or perhaps a spiral galaxy we are seeing at such a perfect angle that its arms are completely hidden, their light lost in the glare of the dense disk. The dust itself is cold and silent now, but its very existence is a clue to a more dynamic history, a last remnant of the raw material that once built this entire stellar island. Gazing at the Spindle is like looking at a clock that has stopped, its hands frozen at a moment when transformation ceased, leaving behind only this perfect, enigmatic silhouette. What other galaxies are quietly holding their secrets in plain sight, their true identities hidden by a simple trick of perspective? While the Spindle galaxy presents a vision of stellar retirement, the ghost of Cassiopeia is a portrait of violent, brilliant birth. Officially catalogued as NGC 281, this sprawling cloud of gas and dust is a cosmic nursery, actively forging new stars from the raw material of the galaxy. Its popular nickname comes from its location, nestled within the distinctive W shape of the constellation Cassiopeia, but its appearance has earned it another, more playful moniker. In wide-field images, the nebula's dark, sweeping dust lanes and bright central cavity create an uncanny resemblance to a certain classic video game character, leading many astronomers to call it the Pac-Man Nebula. This is no static painting of light. It is a dynamic, churning cauldron of creation, and the source of its glow is a group of tremendously hot, young, massive stars known as the Open Cluster IC 1590. These stellar infants, only a few million years old, are the architects of the entire scene. Their intense ultraviolet radiation bombards the surrounding hydrogen gas, stripping electrons from atoms and causing the vast cloud to fluoresce with a characteristic red glow that spans over 100 light-years. But their power does more than just illuminate. The fierce stellar winds streaming from these massive stars act like cosmic sandblasters, carving out vast cavities and bubbles within the nebula. Look closely at the Pac-Man's mouth, and you will see a bright, sculpted rim where this radiation and wind are slamming into the denser walls of gas and dust, compressing it further. This process of compression is the key to the nebula's ongoing story. As the shock fronts push into the cloud, they trigger gravitational collapse in denser pockets, seeding the next generation of stars. Scattered throughout the glowing red gas are dark, inky blotches known as Bok globules. These are dense, cold knots of dust and gas so thick they block all the light behind them. Within these cosmic cocoons, gravity is quietly at work, pulling material together until the pressure and temperature at the core become so extreme that nuclear fusion ignites and a new star flares to life. The ghost of Cassiopeia is therefore a snapshot of a self-perpetuating cycle. The first generation of massive stars, through their very violence, is creating the conditions for their successors. It is a stellar assembly line visible across light years where the death of one cloud gives birth to new suns. This vibrant ghost is a reminder that the cosmos is not a museum, but a workshop, constantly building and rebuilding itself with spectacular energy. The vibrant stellar workshop of the ghost of Cassiopeia shows creation on a grand scale, but some galaxies take that chaos to an almost monstrous extreme. NGC 4194, known as the Medusa Merger, is a cosmic snapshot of pure, tangled violence. This is not a serene spiral or a quiet elliptical, but the still-churning aftermath of a head-on collision between two galaxies that occurred roughly 700 million years ago. The result is a single, grotesquely beautiful entity, a galactic wreck that has earned its mythological name with terrifying accuracy. Its most striking feature is a long, faint streamer of stars and gas that arcs away from the main body, stretching across the void for over 100,000 light-years. This is a tidal tail, material ripped from the galaxies during their close encounter and flung into the darkness by immense gravitational forces. It does not glow with the soft light of a nebula, but with the combined pale shine of millions of orphan stars, a serpentine lock of cosmic hair forever trailing the monstrous head. The core of the Medusa is where the true fury resides. The collision did not just distort shapes, it compressed unimaginable amounts of interstellar gas and dust, funneling it into the galactic center. There, under the crush of this sudden density, a firestorm of starbirth ignited. NGC 4194 is now classified as a starburst galaxy, a term that barely conveys the ferocity of the process. Star formation is not just happening here, it is exploding at a rate hundreds of times faster than in our own tranquil Milky Way. Within the Medusa's heart, vast clusters of brilliant blue supergiant stars are being born in frantic succession, their intense radiation lighting up the surrounding chaos. This frenzy cannot last. Such prodigious star formation consumes the available fuel at a breakneck pace, and the most massive of these new stars will live short, violent lives, ending in supernova explosions that will further churn the galactic stew. The Medusa Merger is a system in the most extreme phase of its life, a temporary and brilliant fever dream triggered by a catastrophic crash. It shows us that sometimes the most luminous and creative forces in the universe are born not from quiet contemplation, but from sheer, unbridled cosmic violence. The chaotic fire of galactic mergers is a spectacle of raw force, but sometimes stellar death produces a shape of startling, almost artificial geometry. Catalogued as NGC 6309, the Box Nebula defies the graceful curves of its planetary nebula cousins. Through a telescope, it presents not a glowing sphere or an elegant hourglass, but a sharp, rectangular patch of greenish light floating against the black. It looks less like a celestial event and more like a window cut into the fabric of space, a perfect, luminous box. This stark shape is an extreme rarity in a cosmos dominated by fluid forms and explosive symmetries. Most planetary nebulae are sculpted by fast winds from a dying star's core inflating slower, earlier ejecta, often resulting in round shells or bipolar lobes that resemble an hourglass. The Box Nebula, however, appears confined, its expansion seemingly halted by invisible walls. How does a star, in the violent act of shedding its atmosphere, create something with such straight edges and right angles? The leading theory points to a hidden girdle, a dense belt or torus of dust and gas that was thrown off by the star's equator during an earlier phase. Imagine a star surrounded by a thick, dusty inner tube. When the later, faster stellar wind begins to blow, it expands rapidly out of the star's poles where the resistance is lowest, but finds its path severely restricted around the equator by this dense girdle. The result is not a free-flowing bubble, but a shape constrained into a rectangular form, with the glowing gas filling the volume inside the torus and streaming more freely from the poles to create the box's structure. High-resolution images hint at this, showing faint extensions protruding from the corners of the box, suggesting gas is indeed finding ways to escape. This makes the Box Nebula a crucial cosmic puzzle box for astrophysicists. Its precise geometry offers a rare, clean laboratory to study the complex interactions between stellar winds and circumstellar material. By deciphering the physics that built this box, we gain deeper insight into the final, sculpted breaths of sun-like stars everywhere. It stands as a quiet, geometric testament to the fact that even in death, a star's history, the specific way it shed its layers, is permanently written in the light it leaves behind. What other impossible shapes are waiting to be decoded in the silent expanses between the stars? The sharp geometry of the Box Nebula is a marvel of constraint, but our next object presents a form defined by breathtaking delicacy. The Silver Needle Galaxy, catalogued as NGC 4244, is a whisper of light stretched across the void. Seen nearly perfectly edge-on from our vantage point, it appears not as a grand spiral or a churning disk, but as an impossibly slender sliver, a luminous filament so thin it seems it might snap under the tension of its own rotation. This is a spiral galaxy in its purest, most minimalist form, stripped of all its grand ornamentation by our perspective. Its spiral arms, which would wrap in magnificent pinwheels if we saw it face-on, are compressed into this single, needle-thin line. The galaxy's core, usually a bright, concentrated bulge, is here just a slight thickening along the needle's length, a faint suggestion of a central hub. What makes the Silver Needle so captivating to astronomers is not just its shape, but its profound dimness. It is classified as a low-surface brightness galaxy, meaning its starlight is spread so thinly across its vast area that it barely outshines the natural glow of the night sky itself. Finding such a galaxy is like trying to see a cloud of smoke against a twilight horizon, a monumental challenge that explains why these ghostly structures have often been overlooked in cosmic surveys. Yet, this very faintness is the key to its greatest secrets. By meticulously mapping the subtle motions of stars and gas within this delicate sliver, astronomers can perform a kind of cosmic autopsy. They can weigh the galaxy with incredible precision, and here lies the profound mystery. The results consistently show there is not nearly enough visible matter, the stars and glowing gas we see in that needle, to explain how fast the galaxy is spinning. According to the laws of gravity, a galaxy spinning that fast should fling its outer stars into the darkness. The fact that it does not, that the Silver Needle holds together in its pristine, slender form, provide some of the cleanest evidence for the existence of dark matter. The galaxy must be embedded within a massive, invisible halo of this mysterious substance, a gravitational scaffold many times larger than the visible needle itself, holding the entire delicate structure together. Studying NGC 4244 is like studying the silhouette of a dancer to understand the strength of the bones within. It allows scientists to probe the hidden architecture of galaxies, revealing that what we see with our eyes is only the luminous tip of a vast dark iceberg. This elegant sliver of starlight, then, is far more than a pretty shape. It is a critical tool for mapping the invisible skeleton of the cosmos. If the Silver Needle Galaxy is a whisper, the Little Gem Nebula is a brilliant shout. Catalogued as NGC 6818, this planetary nebula lives up to its nickname, appearing through a telescope as a small, intensely luminous jewel set against the velvet black of space. Its compact size and remarkable brightness make it a favorite target, a cosmic gemstone easily found in the constellation Sagittarius, but this is no simple glowing ember. High-resolution views reveal a stunning complexity that belies its diminutive name. The nebula possesses a distinct double shell structure, like a brilliant, shimmering soap bubble floating within a larger, more delicate one. The inner shell is sharply defined and dazzlingly bright, fluorescing under the harsh ultraviolet light of the central white dwarf star. Encircling it is a much fainter, more extensive outer envelope of gas, the material expelled during an earlier, quieter phase of the star's death throes. This layered architecture is a fossil record of the star's final millennia, with each shell telling a different chapter of the same story of mass loss. The colors of the little gem are its most captivating feature. It is not a monochrome green, as many planetaries appear to the eye, but a vibrant palette revealed through astrophotography. Hues of blue-green dominate, emanating from doubly ionized oxygen atoms energized by the central star's radiation. Swirls of red from excited hydrogen gas trace intricate structures within the shells, while hints of magenta from nitrogen emissions add further depth to the cosmic portrait. Each color is a direct fingerprint of a specific element that was once fused in the star's core and is now being returned to the interstellar medium. This colorful detail makes NGC 6818 more than just a pretty sight. For astronomers, it serves as a crucial laboratory for understanding the final, delicate dance of intermediate mass stars, those roughly 1 to 8 times the mass of our Sun. By studying the precise structure and chemical composition of its shells, scientists can reverse engineer the process. They can determine the rate at which the star shed its outer layers, the sequence of events that led to the ejection, and even the strength of the stellar winds that sculpted the nebula into its current form. The little gem offers a clear, nearby example of how a typical star peacefully enriches the galaxy with the heavy elements necessary for planets, and ultimately life. It is a brilliant, colorful testament to the fact that even in death, a star sows the seeds for future creation. From the brilliant gem of a dying star, we shift our gaze to a cosmic game of gravitational tug-of-war. Drifting through the constellation Canes Venatusi, the celestial hunt, two galaxies have become so entangled they now form a single, bewildering shape. Together known as the hockey stick galaxies, their catalogue entries are separate, NGC 4656 and NGC 4657, but their forms are now forever merged into a celestial question mark hanging in the void. Through a telescope, the primary galaxy, NGC 4656, appears as a long, slender, and slightly curved shaft of light. At its end, the smaller companion, NGC 4657, forms a distinct, bright, and knotted hook, completing the unmistakable silhouette of a hockey stick or a punctuation mark written in starlight. This is not a static sculpture, but a snapshot of a violent, ongoing process. These two spiral galaxies are caught in a close gravitational embrace, and the immense tidal forces between them have stretched and warped their once graceful structures beyond recognition. The long shaft is a tidal tail, a streamer of stars and gas ripped from the larger galaxy during a close pass and now flung far out into intergalactic space. The hook is the distorted core of the smaller galaxy, twisted and compressed by the encounter. But look closer at that luminous hook and along the length of the stick, and you will see the true legacy of this collision. Scattered like brilliant diamonds along the distorted structure are intense knots of blue-white light. These are not random stars, but massive stellar nurseries, regions where the galactic collision has performed a terrible and beautiful magic. As the two galaxies intermingled, vast clouds of hydrogen gas within them did not simply pass through one another. Instead, they collided and compressed with tremendous force. This sudden, violent increase in density triggered a firestorm of star formation, a starburst on a galactic scale. Each of those bright knots is a superstar cluster, a region where thousands of new stars have ignited simultaneously, many of them monstrously hot, blue supergiants that will burn fiercely and die young. The hockey stick is therefore a galaxy in the midst of reinventing itself through catastrophe. The gravitational dance has destroyed its original spiral symmetry, but in doing so, it has ignited a brilliant, temporary blaze of new creation. This luminous question mark asks us to consider the dual nature of cosmic violence, where destruction and birth are two sides of the same coin, forever linked in the silent, slow-motion ballet of the universe. The brilliant chaos of galactic collisions gives way to a more intimate and strangely biological cosmic structure. The Retina Nebula, catalogued as NGC 2346, floats in the darkness like a colossal, disembodied eye gazing back at us. This planetary nebula is a masterpiece of symmetry, with two luminous lobes expanding away from a dark central waist, creating an uncanny resemblance to the delicate interior of a biological retina. But the true strangeness of this celestial eye lies not in its appearance, but in the remarkable dance happening at its very center. Unlike the solitary white dwarfs that power most planetary nebulae, the heart of the Retina Nebula is a pair of stars locked in a tight, frantic embrace. This is a close binary system where two stars orbit a common center of gravity in a period of just 16 days. Their gravitational partnership is the key sculptor of the entire nebula. Astronomers believe the story began when the more massive of the two stars reached the end of its life. As it swelled into a red giant, it grew so large that it actually engulfed its smaller companion star. For a time, the smaller star orbited inside the bloated atmosphere of its dying partner, a scenario that sounds like science fiction. This intimate dance created tremendous friction and drag, causing the two stars to spiral closer together. This process also whipped the giant's outer layers into a frenzy, ejecting them not in a uniform sphere, but in a dense, slow wind concentrated around the star's equatorial plane like a spinning disk of gas. Later, when the giant's core was finally exposed as a hot white dwarf, it and its companion began blasting out a much faster wind. This fast wind, however, could not expand freely in all directions. It slammed into the dense equatorial disk of older material, which acted like a cosmic barrier, forcing the outflow to channel violently out through the poles of the system. The result is the beautiful bipolar structure we see today, two opposing lobes of gas streaming away from the dark, dusty central belt. The intricate filaments and delicate textures within those lobes, which so vividly mimic the veins of a retina, are the scars of this complex interplay of stellar winds and gravitational tides. The Retina Nebula is therefore a direct fossil of a stellar relationship. Its shape is a permanent record of a celestial dance that spanned millennia, a testament to how the gravitational interplay between two stars can sculpt the final moments of one into a work of breathtaking, symmetrical art. It makes you wonder what other beautiful forms are being shaped right now by unseen stellar companionships in the depths of our galaxy. The intricate dance of binary stars shapes nebulae, but entire galaxies can be spun into chaos by similar gravitational embraces. A mere 30 million light-years away, the Cocoon Galaxy, NGC 4490, is tearing itself apart in a blaze of creation. This is not a serene spiral, but a mangled, luminous wreck, its once elegant arms stretched and twisted into a fuzzy, cocoon-like shape by its ongoing merger with a smaller companion, NGC 4485. The two galaxies have already made their closest pass, and the gravitational aftermath is spectacular. A colossal tidal tail of stars and gas, hundreds of thousands of light-years long, has been ripped from the larger galaxy and flung into the intergalactic void, a shimmering bridge of debris connecting the two distorted cores. This bridge is not empty, it is a highway of material where new star clusters are igniting like streetlights along a cosmic freeway. The entire system is now a single, churning entity, and it is undergoing a ferocious starburst. The violent compression of gas during the merger has triggered star formation at a rate dozens of times faster than in our own Milky Way. Across the mangled body of the cocoon, brilliant blue-white knots blaze with the light of newborn superstar clusters. These are factories churning out massive, hot stars that live fast and die young, their intense radiation lighting up the surrounding chaos and painting the galaxy in vivid hues visible to our telescopes. This incredible activity makes the Cocoon Galaxy one of the most prolific star-forming regions in our entire local universe, a nearby laboratory where we can watch the consequences of a galactic collision unfold in real time by cosmic standards. Studying this system is like having a front-row seat to the process that built many of the giant elliptical galaxies we see today. It shows us that from a violent, disruptive embrace, a new, brighter, and more active galactic entity can be born, wrapped not in silk, but in the luminous threads of a billion new suns. The violent rebirth of colliding galaxies is a spectacle of raw energy, yet a single dying star can craft a world of serene, structured beauty. The blue snowball, catalogued as NGC 7662, is one of the most perfect and brilliant planetary nebulae in the entire sky. Through a telescope, it appears as a small, intensely luminous disk of blue-green light, a flawless celestial marble that seems almost too pristine to be real. Its popular nickname perfectly captures this appearance, a compact, icy-looking orb hanging in the constellation Andromeda. But that simple, beautiful disk is a magnificent illusion. What we perceive as a smooth ball of light is in reality a dynamic and deeply layered structure, the final testament of a star that shed its skin in a series of carefully timed sighs. The overwhelming blue-green color is the key signature of its chemistry. This vivid hue comes primarily from doubly ionized oxygen, atoms that have been stripped of 2 electrons by the fierce ultraviolet radiation blasting from the tiny, searing hot white dwarf star at the nebula's heart. This process of ionization makes the gas flourish with that otherworldly aquamarine glow, a color that has become synonymous with planetary nebulae. Peer deeper, however, and the snowball's true complexity unfolds. High-resolution images from space telescopes reveal it is not a solid ball, but a delicate series of concentric shells like the layers of a cosmic onion. Each faint, ethereal shell represents a distinct episode of mass loss from the progenitor star, a pulse of material ejected thousands of years apart. These shells are not smooth either. They are etched with fine radial streaks, faint streamers that point outward like spokes from the central star. These features are thought to be caused by instabilities at the boundary where the fast wind from the white dwarf collides with the older, slower-moving ejector, creating ripples and filaments in the glowing gas. Furthermore, the innermost region reveals a bright, elongated ring, suggesting that the star's final ejections were not perfectly spherical, but were shaped by a dense equatorial belt, funneling the last gusts of its atmosphere into a more complex form. The blue snowball, then, is a stunning celestial archive. Its nested shells record the star's final millennia in exquisite detail, a timeline of mass loss frozen in expanding gas. Its radial streaks map the turbulent interactions between different stellar winds, and all of this intricate history is contained within that deceptively simple, breathtakingly beautiful blue sphere, a reminder that cosmic perfection often hides profound and turbulent stories just beneath a serene surface. The serene symmetry of the blue snowball is a distant memory when we encounter the cosmic wreckage of NGC 6240. This is the Starfish Galaxy, a name that hints at its sprawling, multi-limbed shape, but fails to convey the sheer violence of its origin. What we are seeing is not a single galaxy, but the still glowing aftermath of a head-on collision between two massive spiral galaxies, each likely as large as our own Milky Way. Their merger is not a future event, but one that is already deep in progress, and the result is a chaotic, luminous beast classified as an ultra-luminous infrared galaxy. Its light, overwhelmingly emitted as heat, is not from stars alone, but from vast shrouds of dust, heated to incandescence by the frenzy within. The galaxy's bizarre, irregular body is stretched into long, looping tidal tails of stars flung into the darkness, giving it that starfish-like silhouette. These tails are the gravitational signatures of the catastrophe, the place where billions of stars were torn from their original orbits and cast adrift. At the heart of this chaos, astronomers expected to find a single, monstrous supermassive black hole, the combined core of the two former galaxies. Instead, they found something far more extraordinary. High-resolution observations revealed not one, but two brilliant, active nuclei blazing side by side in the galactic center. Each is a supermassive black hole, the relic core of one of the original galaxies, now trapped in a mutual gravitational embrace. They are separated by a mere 3,000 light-years, which is cosmically intimate, and they are slowly, inexorably spiraling toward one another. As they circle, they stir the remaining gas and dust into a maelstrom, fueling incredible bursts of star formation and generating intense radiation that lights up the entire system. This binary black hole system is a rare and precious sight, a snapshot of a pivotal moment in galactic evolution. Their eventual merger, millions of years from now, will send powerful ripples through the fabric of spacetime itself, gravitational waves that will echo across the universe. The Starfish Galaxy is a preview of our own distant future, when the Milky Way and Andromeda will collide, and it shows us that the most luminous, turbulent objects in the cosmos are often just the opening act for an even more profound and invisible finale. Even the most chaotic galactic wreckage eventually settles, but the final breath of a single star can leave a signature of startling precision. The Phantom Streak Nebula, catalogued as NGC 6741, is a masterclass in subtlety and a true test for an observer's skill. In a telescope, it does not appear as a glowing disk or a complex hourglass. Instead, it reveals itself as an elusive, incredibly thin sliver of pale light, a ghostly scratch against the darkness. Its faintness and elongated form make it a challenging target, often requiring averted vision and a dark sky to even glimpse, earning its phantom moniker. This appearance is no accident of perspective, but the direct result of its three-dimensional geometry seen from a very specific angle. The Phantom Streak is a bipolar planetary nebula, a type shaped by fast outflows from a dying star's poles. We are not looking at it from the top or bottom where it might show symmetrical lobes. We are viewing it almost perfectly edge-on, staring directly into its narrow equatorial plane. From this vantage, the two expansive lobes are compressed into that single, razor-thin line of light, with a dense central waste of dust and gas blocking our view of the glowing cavities on either side. It is like viewing a winged pendant from the side, where the wings disappear and only the thin central jewel remains visible. The forces that carved this shape were extreme. Astronomers believe the progenitor star did not shed its atmosphere calmly. In its final phases, it likely ejected high-speed jets of material from its poles at velocities reaching hundreds of kilometers per second. These jets, acting like cosmic blowtorches, punch through the slower-moving envelope of gas ejected earlier, carving out the bipolar cavities and giving the nebula its elongated structure. Now, at the heart of this faint streak, the star's exposed core is completing its transformation. It is an exceptionally hot pre-white dwarf, a stellar ember with a surface temperature soaring to over 200,000 degrees Celsius. This tiny, ferocious engine is responsible for making the entire nebula fluoresce, its intense ultraviolet radiation exciting the atoms in the surrounding gas and causing that faint, ethereal glow we struggle to see. The phantom streak, therefore, represents a very brief and advanced stage in a planetary nebula's life. The shaping jets have likely subsided, the central star is nearing its final white dwarf state, and the nebula itself is expanding and fading into the interstellar medium. To find it is to capture a ghost in the act of vanishing, a final, precise geometry etched in light just before it dissipates forever into the galactic background. The Phantom Streak Nebula fades into the cosmic background, a ghost written in light, but our own galactic neighborhood holds phantoms of a far grander and more mysterious scale. Orbiting the brilliant, dusty whirlpool of the Sculptor Galaxy, a mere 11 million light-years away, is one of the faintest objects ever catalogued. Designated NGC 253-DW1, it is not a glowing nebula or a sparkling cluster, but an entire galaxy, a companion so dim it was only recently pulled from the shadows by the most sensitive telescopes. This is a dwarf spheroidal galaxy, a class of objects that are the true ghosts of the cosmos. Imagine a volume of space as large as the Milky Way, but containing only a few 100 million stars, a number that pales in comparison to our galaxy's hundreds of billions. The stars in this dwarf are ancient, faint, and widely scattered, producing so little combined light that the galaxy's total luminosity is less than that of a single bright star in a globular cluster. You could look directly through this galaxy with a backyard telescope and see nothing but empty space behind it. Its near invisibility is the first clue to its profound strangeness, because despite having almost no visible matter, these galaxies possess immense gravitational pull. Measurements of the motions of their scant stars reveal they are moving far too quickly to be held together by the gravity of the stars we see. The only explanation is that each dwarf spheroidal is absolutely filled with and dominated by dark matter. They are not just galaxies with some dark matter, they are dark matter halos that, almost as an afterthought, manage to collect a tiny smattering of stars. This makes objects like NGC 253-DW1 not cosmic curiosities, but among the most valuable laboratories in the universe, for scientists testing theories of galaxy formation and the very nature of dark matter itself. These faint smudges are pure gold. The prevailing model of cosmology suggests that the large galaxies we see, like the Sculptor Galaxy or our Milky Way, were built over time by the mergers and accretion of countless smaller building blocks, precisely these kinds of dwarf galaxies. Finding them, studying their distribution, and mapping their dark matter content allows astronomers to check if the universe is assembling itself according to the theoretical blueprint. Furthermore, because they are so dark matter rich, they are ideal places to search for indirect signals of dark matter particles annihilating with one another, a potential whisper of the universe's greatest unseen component. So this faint companion, this ghost clinging to a brilliant spiral, is far more than a side note. It is a fundamental piece of the cosmic architecture, a silent, shadowy testament to the hidden framework upon which all the luminous beauty of the universe is built. That ghostly dwarf galaxy is a whisper of the universe's hidden mass, but some stellar death shout their structure across the light years. Gracing the southern constellation Vela, NGC 3132 is a masterpiece of symmetry, often called the Eight-Burst Nebula for its intricate petal-like appearance. This is the Southern Ring Nebula, a breathtaking bipolar planetary nebula that looks like a luminous hourglass sculpted from stardust. two opposing lobes of glowing gas, tinted in ethereal blues and warm reds, expand away from a dark, pinched central waist, creating a shape of perfect balance. The source of its glow is a binary star system nestled at its heart, a celestial partnership that holds the key to this stunning geometry. The brighter of the two stars is a white dwarf, the hot, dense core left behind after its outer layers were expelled. But it is the fainter, sun-like companion star that may be the true architect. Astronomers theorize that as the dying star swelled into a red giant, its gravitational dance with this companion star funneled the ejected material. The companion's orbit could have acted like a cosmic spoon, stirring the outflow and shaping it into that dense equatorial ring we see as the dark waste, forcing the faster winds from the white dwarf to escape dramatically through the poles, inflating the two magnificent lobes. This stands in stark contrast to its more famous northern cousin, the ring nebula Messier 57. While both are planetary nebulae, their appearances tell different stories. The classic ring nebula appears as a nearly perfect, smoke-like circle because we are looking directly down the barrel of a dying star's outflow, like staring into a hollow tube. The southern ring, however, offers a three-dimensional view. We see its hourglass shape from the side, revealing the complex structure hidden within the ring's simpler profile. The eighth burst is not just a pretty face, it is a dynamic laboratory. Its lobes are filled with delicate filaments and concentric shells, evidence of multiple pulses of material ejected at different times and speeds. The red glow from nitrogen traces the older, slower-moving gas, while the blue from oxygen maps the younger, faster shock fronts. This colorful complexity makes it a favorite target for telescopes, a celestial flower blooming from the ashes of a star, its form forever shaped by the silent gravitational dance of its stellar companion. The southern ring's delicate hourglass reveals the artistry of stellar death, but some galaxies bear scars of a far more violent and spectacular collision. Among the most famous is the Cartwheel Galaxy, a name that evokes its bizarre, wagon wheel-like appearance. Officially, it resides in the Eskimo Catalogue, but it is so often linked with the new General Catalogue by its discoverer that many still reference it as NGC 224. This small discrepancy highlights a vital truth in astronomy. Our maps of the sky are not single, monolithic documents, but a tapestry woven from many overlapping surveys, each adding new layers of detail and sometimes new names for the same breathtaking sight. And the Cartwheel is truly breathtaking. It hangs roughly 500 million light-years away, a colossal ring of brilliant blue light, 150,000 light-years across, surrounding a dimmer, yellowish central hub. Connecting the hub to the outer ring are faint, spoke-like filaments of stars and dust, completing the uncanny resemblance to a discarded toy wheel spinning in the void. This is not the result of serene evolution, but of a cosmic catastrophe of unimaginable force. Several 100 million years ago, a smaller, compact galaxy, one of the two companions still visible nearby, shot like a bullet directly through the heart of what was then a normal spiral galaxy. Think of a stone dropped into a still pond. The gravitational shockwave from this direct hit did not create water ripples, but a titanic ripple of compressed gas and dust that raced outward from the point of impact at supersonic speeds. This expanding wave of density triggered a firestorm of star formation in its wake. The dazzling blue ring we see is not a solid structure, but the leading edge of that shockwave, a frontier where billions of new, massive, and intensely hot stars have ignited in a frantic, luminous circle. These stars are so young, many are only a few million years old, and their brilliant blue-white light dominates the galaxy's appearance. Meanwhile, the galaxy's original core, the central hub, was left reeling from the impact. Its star formation was largely quenched by the event, leaving behind an older, redder population of stars that now sit quietly inside the maelstrom of their own making. The faint spokes are the shredded remnants of the galaxy's original spiral arms, stretched and distorted by the gravitational encounter, now serving as tenuous bridges between its past and its violently reshaped present. The Cartwheel Galaxy is a snapshot of a galaxy caught in the act of reinventing itself through trauma. It shows us that the most dramatic changes in the universe are not always slow and graceful, but can arrive with the sudden, creative violence of a celestial bullseye, painting a perfect circle of newborn suns across the darkness. The Cartwheel's violent rebirth is a spectacle impossible to miss, yet some of the universe's grandest designs are masters of disguise. In the crowded heart of the Virgo cluster, a magnificent spiral galaxy hides in plain sight. Through the eyepiece of a modest telescope, NGC 4535 is a profound disappointment. It reveals itself not as a whirlpool of stars, but as a faint, uniform smudge of grayish light, a ghostly patch so elusive and featureless it earned the melancholy nickname the Lost Galaxy. Visual observer Leland S. Copeland coined this title, capturing the frustration of searching for a cosmic landmark that seems to dissolve into the background sky, forever just beyond clear perception. This is a galaxy that feels forgotten, a whisper lost in the stellar noise, but switch from the human eye to the patient gaze of a camera, and the truth is breathtaking. Long-exposure photographs unveil NGC 4535 as a stunning grand design spiral, a textbook example of cosmic architecture. Its arms, traced by dark dust lanes and studded with pink star-forming regions, wind tightly around a bright yellow core with majestic symmetry. It is not lost at all. It is one of the most perfectly structured spirals in the entire cluster. This dramatic disconnect between what we see and what truly exists highlights a profound and subjective truth about astronomy. Observation is not a passive act. It is a negotiation between the object's intrinsic light, the instrument's gathering power, and the observer's own perception. The faint, ghostly view in a small scope is not wrong. It is simply one reality, a raw visual experience of a distant island universe whose light has traveled 50 million years only to be diluted by our atmosphere and the limitations of our eyes. The glorious photographic image is another, a compiled truth built from accumulated photons that our biology cannot naturally gather. The Lost Galaxy, therefore, is a philosophical riddle as much as a celestial target. It asks us where a galaxy truly exists. Is it in the faint smudge we struggle to see, or in the brilliant spiral we know is there? It embodies the haunting gap between the universe as it is and the universe as we experience it. A reminder that sometimes the most beautiful truths are not immediately given but patiently revealed. The Lost Galaxy reveals the gap between perception and reality, but the next object hides a furious, rhythmic heart within a shell of deceptive chaos. NGC 1501, the Celestial Geode, is a planetary nebula that looks like a cosmic sponge or a cracked, luminous stone held up to the sky. Its form is utterly unlike the smooth rings or perfect hourglasses we have seen. Instead, it presents a bubbly, mottled, and wildly irregular surface, a shell of gas that seems to have been frozen mid-boil. This textured, cavernous appearance comes from a complex inner structure. We are not looking at a solid ball of light, but at the illuminated walls of a vast off-center cavity. The dying star at its heart did not eject its atmosphere evenly. It blew fierce, chaotic winds that carved out a bubble within the surrounding cloud, and now we see the glowing, ragged boundaries of that hollow space, giving the entire nebula its deeply three-dimensional, geode-like quality. Yet the true engine of strangeness here is invisible to the eye. At the very center of this gaseous labyrinth spins a star that refuses to go quietly. The central white dwarf is a rapid pulsator, a stellar ember that rhythmically expands and contracts, changing its brightness noticeably every couple of hours. This constant heartbeat-like throbbing sends waves of varying ultraviolet radiation flooding into the surrounding nebula. As the star brightens and dims, it causes the entire geode to flicker in response, its complex filaments and bubbles glowing slightly brighter, then slightly fainter, in a silent, cosmic echo of the star's final tremors. For astronomers, this makes NGC 1501 a living laboratory. By monitoring the precise timing of the central star's pulses and correlating them with the subtle brightness changes in different parts of the nebula, scientists can perform a kind of cosmic tomography. They can measure how long the star's light takes to reach various parts of the nebula's shell, effectively mapping the three-dimensional structure of the cavity. More profoundly, they can study the transfer of energy from a dying star to its funeral shroud in real time. Each pulse is a probe, testing the density and composition of the gas, revealing details about the star's final mass loss and the physical conditions within the nebula. This celestial geode, therefore, is more than a static sculpture. It is a dynamic system, a feedback loop between a trembling stellar remnant and the magnificent tomb it has built for itself. Its chaotic beauty is a direct reflection of the turbulent, unstable processes that govern a star's very last breaths before it settles into eternal silence. That pulsating geode shows a star's final, rhythmic tremors, while an entire galaxy nearby is caught in a state of permanent, lopsided frenzy. NGC 1313, the topsy-turvy galaxy, spins in our cosmic backyard just 14 million light-years away, close enough for its details to be scrutinized, yet what we see defies every expectation for a barred spiral. Its shape is the first clue that something is profoundly wrong. Most spirals, like the majestic Andromeda Galaxy or our own Milky Way, possess a serene, almost mathematical symmetry, with arms winding gracefully from a central bar or bulge. NGC 1313 has no such grace. It is a lopsided, tangled mess. Its spiral arms are shredded and chaotic, one appearing stubby and stunted while the other stretches out into a faint, distorted streamer. Its central bar, the dense lane of stars that usually acts as the galaxy's backbone, is twisted and off-center, as if the entire structure has been grabbed by a giant hand and given a violent, sideways wrench. This is not the result of a recent collision with another galaxy. There is no obvious culprit nearby. Instead, astronomers suspect a different, more ancient trauma. The topsy-turvy galaxy likely devoured a smaller, gas-rich companion galaxy billions of years ago. The digestion was never completed cleanly, leaving the larger galaxy permanently unbalanced, its stars and gas sloshing in a gravitational hangover that has never settled. This internal turmoil has ignited a firestorm. The galaxy is a starburst, forming new stars at a rate that puts our quiet Milky Way to shame. Scattered across its distorted disk are brilliant pink knots and blue-white blazes, each one a vast stellar nursery where thousands of stars are being born simultaneously. The intense radiation from these young, massive stars lights up surrounding gas clouds, painting the chaotic scene in vivid hues. But the true astrophysical anomalies are hidden, detectable only by instruments that see the universe in X-ray vision. Nestled within those star-forming regions are several ultra-luminous X-ray sources, objects so powerful they outshine the entire X-ray output of a typical star-forming region. A single one of these sources can emit more X-ray power than 1 million suns emit across all wavelengths. What could possibly generate such ferocious energy? The leading and thrilling explanation is that we are witnessing intermediate mass black holes actively feeding. These would be cosmic monsters with masses hundreds or even thousands of times that of our Sun, a class of black hole that has been notoriously difficult to confirm. They are the missing link between the stellar mass black holes formed from collapsing stars and the supermassive giants that lurk in galactic cores. In NGC 1313, these potential beasts seem to be gorging on material torn from a companion star or from the dense gas clouds of the stellar nursery itself, releasing torrents of X-rays in the process. This galaxy, therefore, is a triple anomaly, a distorted shape from a forgotten crash, a brilliant blaze of new suns, and a hiding place for elusive middleweight predators of the cosmos. It proves that chaos is not just destructive, it can be the engine for the most extreme and mysterious phenomena in the universe. Our final strange object is a masterpiece of cosmic violence frozen in time. NGC 7027 is the youngest, densest, and most complex planetary nebula known, a stellar explosion caught in the act. Through the Hubble Space Telescope, it reveals itself not as a gentle ring or a smooth sphere, but as a brilliant, rectangular jewel box of light, its edges sharp and defined. Within that box, chaos reigns. A dazzling array of structures fights for attention. Luminous jets scream from the central star, expanding lobes of gas collide, and countless bright knots, like diamonds scattered on velvet, trace patterns of unimaginable turbulence. This is not a serene final portrait. It is a snapshot of a star's death throes happening right now. A stellar catastrophe unfolding so recently that the light we see left the nebula a mere 600 years after the main ejection began. That incredible youth is what makes NGC 7027 a Rosetta Stone for astronomers. Its proximity and intense brightness allow our telescopes to dissect its structure in phenomenal detail, offering a clear view into the violent and poorly understood transition from a puffed-up red giant to an exposed, searing white dwarf. We are witnessing the moment the star's hidden engine is finally revealed. The prevailing theory suggests a dramatic story. The central star, likely once part of a binary system, shed its outer layers in a series of eruptive events. First, it expelled a slow, dense wind of gas, forming a vast, cool envelope. Then, in a convulsive final act, the star's core blasted out a supersonic wind of particles moving at millions of kilometers per hour. This fast wind is now slamming into the older, slower-moving ejector, carving it, heating it, and sculpting the intricate landscape we see. Those brilliant jets are evidence of even more focused outflows, possibly channeled by the star's magnetic field or the gravitational influence of a companion, punching through the chaos like cosmic blowtorches. Every color in Hubble's iconic image is a clue. The red filaments trace cool molecular hydrogen, the remnants of the star's outer atmosphere. The green regions map hot, ionized gas, while the blue highlights the ferocious shock fronts where the fast wind collides with the slower shell. By studying this luminous forensic evidence, scientists can clock the speeds of the outflows, measure the mass of the ejected material, and even estimate the temperature and luminosity of the central star with unprecedented precision. NGC 7027 concludes our journey through the new General Catalogue not with a whisper but with a shout. It reminds us that the catalogue is not a graveyard of static wonders, but a living album of cosmic processes. From the ghostly gaze of the ghost of Jupiter to the violent, youthful chaos of this final entry, these 25 objects showcase the universe's boundless creativity. They prove that within a simple numerical listing, the deepest mysteries of birth, death, and transformation are waiting, written in light for anyone who knows where to look. From violent stellar births to silent, ancient dwarfs, the new General Catalogue is far more than a dry astronomical index. It is a treasure map to the universe's strangest corners, a curated collection of cosmic anomalies that defy simple explanation. We have wandered past ghostly planetary nebulae, their intricate shapes sculpted by dying stars and hidden companions. We have witnessed galaxies torn apart by gravitational embraces, their collisions igniting firestorms of new suns. We have seen perfect geometric forms emerge from chaos and watched as invisible dark matter revealed its presence only through the silent spin of a faint stellar needle. Each catalogue number unlocks a story, a unique snapshot of physics operating at its most extreme and beautiful. These 25 objects are just the beginning. Hundreds more strange sights wait within the NGC's pages, each one a challenge to our imagination and an invitation to look deeper. The true wonder is that this map is accessible to anyone. With a small telescope under a dark sky, you can find the ghost of Jupiter or the Blinking Nebula for yourself. With a quick search online, you can lose yourself in the Hubble images of the Cartwheel Galaxy or the Retina Nebula, exploring details no human eye could ever see directly. The cosmos is not a distant abstraction. It is a gallery of active, evolving wonders, and the NGC is your guidebook. So the next time you look up at the stars, remember the strange and spectacular reality hiding behind those simple numbers. Which of these cosmic oddities captured your imagination the most? Let us know in the comments below. And if you enjoyed this journey through the catalogue's strangest entries, be sure to like and subscribe for more explorations into the mysteries of space.